Okay, so we are now going to start proofs, the basics of proofs, and we're going to go over all the different important bits of information, and then moving on from here on out, I would anticipate each section, at least with this first chapter, definitely incorporating proofs into what we're going to do. So we're not doing this all year long. There's just a couple chapters that we are going to have this included in, and this is definitely one of them. So when we talk about writing proofs, a postulate or axiom is a statement that's accepted as true without proofs. So basic ideas about points, lines, planes, like the vocabulary basically that we've gone over, can be stated as postulates. So if we have this huge chart right here, okay? So it says through any 2 points, there's exactly one line. That's the definition of a line. Through any 3 non-collinear points, there's a plane. A line contains at least 2 points. A plane contains at least 3 non-collinear points, and so on. So each of these are just, it's vocabulary based, okay? So a proof, it's a logical argument in which each statement is supported by a definition, a postulate, or a theorem. And what we're going to focus on in geometry are things called 2-column proofs. So we're going to be creating 2-column charts. The left column is going to be our statement side, and then the right column is our reasoning. How are we saying what we're saying in the statement side? We've got to justify it. So there's some important things we need to keep in mind. The first statement is always what's given, and that will be always written down for you. You just need to copy it. And the last statement is always what you have to prove. And then on the flip side, on the reason side, you're going to write the word given for the first one. And again, this is brand new to you. So what we're going to do is we're going to start out with the algebraic proofs first before we add the geometric ones in the next section. So there's both algebraic and geometric proofs. For algebraic proofs, the following properties are used to justify. So these are all properties from Algebra 1. We have the addition property of equality, subtraction, multiplication, division, reflexive, symmetric, transitive, substitution, and distribution. So I would say these are definitely most popular in terms of you're going to see them often. But for right now with the algebraic proofs, you're going to see a lot with the operations above in terms of adding, subtracting, multiplying, and dividing. So we're going to start very slow, and we're going to just focus on the algebraic proofs today. And then come next time, we're going to start incorporating the geometric stuff into the mix. So it's always good to start with the algebraic just because many of us know how to solve an algebra problem. So that's basically what we're doing. We're just going to write it in a different format. So remember, we're doing 2-column proofs. So example 1 says, given y plus 2 over 3 equals 3, we want to prove that y equals 7. Well, it says 2-column proof. So we have 2 columns. Left column is our statement column, and the right side is our reason column. Okay, on the front page of the notes, it had said that the first statement is what the given says. Well, this is what the given says. So I am just going to number it number 1, and I'm going to recopy exactly what the given says. Okay, now your first reason was the third bullet point on that front page. Your first reason, why am I saying that? Well, that was given to me, so I'm writing the word given. The nice part about proofs is this first line is automatic. You should know exactly what to write here now. Moving forward, the first statement is always what it says next to the word given, and the first reason is always the word given. So now what we're going to do is we're basically solving the algebra problem. We're just, instead of showing work how we usually did, we just now have to justify every single step. So line 2 is now going to say, okay, well, I've got to solve for y. So what should I do first? Some people might look at this and say, okay, well, I'm going to multiply by 3. So if I multiply both sides by 3, I'm going to then write for my next line, y plus 2 equals 9, because I multiplied again, both sides by 3. And now, not just the left side you have to fill in, but you have to say what you did. So what did we do? We multiplied by 3. So reason 2 is multiplication. You're identifying what the operation is. You don't have to say what you're multiplying by. You can just tell me what the property is. And then for line 3, I've got to get y by itself. So I'm going to say it says y plus 2, so I'm going to subtract 2. So when I subtract 2, I get y equals 7. And what did I do? Well, subtraction. Now, if you look back on the front page of the notes, the first bullet point said that the first statement was the given. The third bullet point said that the first reason was the word given. And then the second bullet point said that your last and final statement should be what the given or what the prove statement says, which if we look at line 3, we were trying to prove that y equals 7, and that is in fact what that final statement says. Okay, so again, we're getting more comfortable or starting to get us to think more in a 2-column format. Okay, again, we're not going to do crazy amounts of proofs, but realize that this is part of the geometry curriculum, so we are going to be touching on proofs. But the nice thing is, when you see that you have to do a proof, here's your general setup. 2 columns, left side is statements, right side is reasons, 1 and 1. You know stuff has to go there. The first statement, again, is what the given says. So -5, parentheses, x plus 4 equals 70. You know your first reason is the word given. Now we've got to figure out, all right, my goal is to solve for x. So what am I going to do first? Well, I should probably get rid of the parentheses. In order to do that, I have to distribute the -5. So when I distribute the -5, I get -5x minus 20 equals 70. And what's my reason? What did I do? I distributed, or distribution. Sorry, it cut off. Now for line 3, I got to get that x by itself. So what I'm going to do, is bring the 20 to the other side. So if I bring the 20 to the other side, I now have 90. And what did I do? Well, I added. So this is addition. And then again, still getting the x by itself. What I'm going to do is I'm going to divide by -5 on both sides. So when I divide, I get x equals -18. My reason is division.